In this video, we will talk about using the reaction quotient, that is Q, and comparing it to Ksp. So knowing the Ksp of barium carbonate, if we mix barium ion and carbonate ion, is at those concentrations and those volumes, will it be enough to cause the precipitation of barium carbonate who has a Ksp? Barium carbonate is a sparingly soluble solid. So barium nitrate, first and foremost, is a source of barium ion. All nitrates are soluble. Sodium carbonate is a source of carbonate ions. Sodium carbonate is soluble in water. So the barium ions will react with the carbonate ions to give you barium carbonate. Barium carbonate will be a precipitate, but it's not 100% precipitate because it's what is known as a sparingly soluble solid. The Ksp, we look at this in the table or in our textbook, and it's 8.1 times 10 to the minus 9. So some of that barium carbonate will go into barium ion and carbonate ion. Will it, at these concentrations and volumes, we have to calculate Q and compare it to Ksp. So we will find the final concentration of the barium ion, final concentration of the carbonate ion, get Q. If it's greater than Qsp, look at where the arrows point. They're going to point to the left-hand side, so that means a precipitate will form. If the Q is less than Ksp, in this situation you always want to put Q first. The arrow or the alligator jaw is pointing towards the right-hand side, towards the ions, barium and carbonate ion, and so it will not precipitate. And finally, if Q equals Ksp, we have what is called a saturated solution. It's at the cusp of forming a precipitate, but really it's sort of at the solution state as well as at the precipitate state. We call that a saturated solution. Most important thing to do when starting any of these equations is to actually write the Ksp chemical equation that defines a sparingly soluble solid. In this case, it's barium carbonate, and it is at an equilibrium with barium ion and carbonate ion. Remember, carbonate ion has the formula CO3 minus 2. Barium ion has the formula Ba plus 2. It's an ionic compound that will form a precipitate. The Ksp is 8.1 times 10 to the minus 9 at a specific temperature. In this case, we can assume it's at room temperature. So sparingly soluble solid, 100% of the solid will not be in the form of barium carbonate. Some small amount will go back to the right-hand side of this equilibrium. Now we need to write our Ksp. Solids do not go into our equilibrium expression, neither do liquids. So the Ksp is just going to be barium ion times the carbonate ion. In our ice table, instead of using X, we will use S. The S stands for solubility. Let's figure out the concentration of the barium ion first. According to the problem, we have 20 milliliters, and the concentration is 0.10 molar. The total volume, after we mix these two, is 20 milliliters of 0.1 molar, added to 50 milliliters, so 20 plus 50 is 70 milliliters. The mils cancel, and on this calculator, this will yield an answer of about 0.286 big M, that is moles per liter molar. We're going to do the same thing with the carbonate ion. Carbonate ion comes from sodium carbonate. Remember, the sodium ion is a spectator ion here. The nitrate ion is a spectator ion here. They are dissolved in water and will not react. So the carbonate here is 50 milliliters according to the problem. The concentration is also 0.1 molar, and the total volume here is 70 milliliters. So after mixing both of these up, 50 plus 20 is 70 milliliters as before. The mils cancel. This yields a concentration of carbonate ion of 0.0714 big M molar. And now we will put this into our Ksp expression. The Ksp is equal to products over reactants, but because the product is a solid, we do not add it to our Ksp. Solids do not have a concentration. They basically have a density, so solids will not go. And we're going to put in our values here of S of 0.286 and 0.0714 and compare it to Ksp. So we're going to call this actually Q. Q has the same formula of Ksp, but we'll use it as a comparison. So barium ion plus the carbonate ion. If Q equals Ksp, we have what's called a saturated solution. So barium ion is 0.286. I'm not going to put units here because these Ks have no units. Let's compare it to Ksp. We're going to put Q first here. So we have 0.0242. Compare it to 8.1 times 10 to the minus 9. And yes, resoundingly, Q is much, much greater than Ksp. And so where do the arrows point? The alligator claws or the jaws or however you want to phrase it point to the side of the precipitate. So the precipitate here is where the equilibrium shifts. So yes, if you mix these two substances together at these concentrations, you will definitely get a precipitate. And the answer is a resounding yes, there is a precipitate when you mix barium ion from barium nitrate with carbonate ion from sodium carbonate.